Small details. All right, we are started now. So, all right. So let me. So what was your question? So Brooke started off with a question before we started broadcasting. What was your question, Brooke?
For the individual preparation, can we go over 3B?
3B?
Yeah. What is the 40th percentile for this population?
Oh, that one took me so long to figure out.
Oh, that's okay. Do you guys? Sorry, I'm talking really loud. My son's sleeping. Here, let me screen share real quick. So what I did at least is, let's see. All right, let me pull up the app with
So, Brooke, do you remember when I think this was the time that Spencer was gone? You, me, and Mike were going over it, and we got one wrong on the quiz, and we had to do that weird goal seek thing.
Mm-hmm.
Is
this the same concept?
Kind of problem. It's the same concept, yeah.
Yeah, you just put in the probability applet, the 40%, the 0.4, and then you can pull it from that.
And then it gives you your z-score, and then you have to solve for that one value.
Okay.
Mm-hmm. Makes sense. So if it gives,
Yeah, that makes sense.
So
okay.
Fairly soon.
Sorry, ignore my loud pen noises in the background.
No, you're good. All right, let me pull off the screen. Okay. But yeah, it's, if you don't know what you're looking for, yeah, I can definitely see where that'd be an issue, but because the probability applet helps a lot.
Yeah, it does.
Because once you start getting it rolling.
Because we're going to need that.
What are you saying, man? You're cutting out.
Oh, I'm saying I should probably pull that up because we're going to need that for the assignment.
Mm-hmm. Yep. Cody, did you have any questions? We'll give him a second to answer. Cody, unfortunately, still can't figure out his mic or camera, so he's outside in our group chat. I got them all figured out this week. Thanks, guys. Cool. All right. Any other questions we have before we go to the group assignment?
No.
All right. Let's get rolling. Less than 7. True and true. Love you, buddy. All right, you guys ready?
Yep.
I'm gonna pull. I got my pen right here. There we go. Pen and paper. Okay. So first says use a normal probability applet to find the combined area of the standard normal curve that is at a z-score of 1.38 to 1.358. 1.358. Okay. 0.358. Okay, so what's the combined area at? So the probability applet says 8.255, so 8.26.
So,
or excuse me, 0.0.
So we're supposed to do everything to the right of and to the left of. So I don't think that it's the middle. Yeah, so it's not directly under.
Oh, excuse me, you're right, yeah. I don't.
So 0.1.
0.175. All right. Which of the following have smaller standard deviation if 9 observations are drawn from a population? The distribution of individual observations. X. The distribution of sample means cannot be determined from the info. I don't know. What do you guys think?
I kind of want to say you can't determine it.
That's what I like. I don't know how you're supposed to determine that.
That seems like a really random question.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from population?
And Cody also says that he thinks that we can't determine it.
Okay.
The other thing
let's
we
just
can
go
do
with
for
that.
that question is I agree with you that I think this cannot be determined, but the other thing we can do is we can have one person submit it, and if they get that question wrong, then we still have more chances to get it right.
Yeah,
Mhm.
totally.
Okay. Which of the following result implies the spread of X decreases as the sample size increases?
I think that's the law of large numbers.
Mm-hmm.
Right. Scores on a quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Dan earned a score of 160 on a quantitative portion of the GRE. What is the Z-score corresponding to Dan's score? So 160 minus 150.8 divided by 8.8.
$1.05.
Or 1.045 rounded to what it's asking for.
Yeah,
Mhm.
sorry, I missed the 3 decimal part.
Yep.
Okay, so question about that. So the formula is value minus mean divided by the standard deviation. But then if you scroll to the end of the lesson for standard deviation, it's the standard deviation divided by the square root of n. So when does the square root of n apply and not apply? Like in this case, we don't have an n, so does my question make sense? Like when do you have to include the square root of n to find your standard deviation?
When a standard deviation isn't given and you're given an n, I think.
Okay. Maybe that was
I
a really simple question, but
I don't. I honestly.
No, so I think from what I've been using on the homeworks and whatnot, there are 3 different formulas that you use. So for example, if you're given the standard deviation of a population, and then you're given the sample size, you use the formula you just mentioned first. That's what you use that one for. If you're trying to find the standard deviation of a sample from a population. Does that make sense? I'm sorry. I don't know if that makes sense. I just know that there are 3 different formulas that we're supposed to use for different situations.
That makes sense. No, that was my question because there are a bunch of different formulas to find the z-score. So yeah.
Mm-hmm.
Yeah,
Okay,
and I think what's helping me is there's only 2 different formulas that help you to find the z-score. One of them, it gives you a sample size, and one of them it doesn't. So depending on if they give you a sample size or not, you use one formula versus the other. And then the one we were just talking about has nothing to do with the z-score.
Okay.
All right. So question 7 is, I would say, what is the probability of randomly selecting a student that will score above a 160 on the quantitative portion of the GRE? 0.148 is what I got.
Mm-hmm.
Yep.
Okay. Random sample of 5 students was selected to take the GRE. Their scores are, what is the z-score corresponding to the sample mean of the student's score? So 160. The sample mean was 160, wasn't it? That's what I got.
Got.
So is this when we use the other formula, or we use the square root of n, or do we just use? Well, I guess we have the what's it called, huh? So it's only gonna be the same 1.045, right?
I
Or
got
not?
2.338.
Because 160 is the same
Because-
one we were just dealing with. Or are we taking the square root? Are we taking the square root of n?
Yeah, so you're taking, yeah, so it's that formula now.
Okay.
So this one is value minus mean divided by standard deviation divided by the square root of n, which is the sample size.
So it would be the 8.8 divided by the square root of 5.
Right. And that's your denominator, and then your numerator is the 160 minus 150.8.
Mm-hmm.
Right. And because I'm lazy, I just created an Excel spreadsheet that does all this for me. So I don't know if I can explain
That's not
it.
laziness. That's
That's
yeah.
efficiency.
Okay.
Yeah.
Okay.
So what was the answer again? Sorry.
I got 2.338.
Okay.
Is there anybody else that agrees with that?
No, sounds
Give me
right.
1 second.
Cody, any thoughts?
Yeah, 2.338.
Good deal.
What was the probability? 5 students are right. 5 students randomly selected will have a mean score that is greater than the mean achieved by the students in the previous.
Oh, okay. So this is the applet here.
.338. So wait, which part of the graph are we wanting?
So what's the probability the 5 students will have a mean score greater than the mean achieved? Okay, so it's just the right, I think.
Yeah.
I think. Yeah,
Okay.
because it was a positive 2.338.
So it'd be,
I'm getting 0.0097.
yeah.
Yeah,
So
so,
it'd be
so how do we round
point
that?
0. I would say 0.01.
Oh, wait, this one is saying that we're supposed to put it to 4 decimal places.
Oh,
Oh, okay.
okay. Perfect. There we go.
That makes our lives easier.
Yeah, it does.
Okay. Suppose the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of random variable x, which represents the sample mean of 81 students who are selected? Would it stay left skewed, or would it therefore, because it's more than 30, be approximately normal?
I think it
I
would be
think-
approximately normal.
I agree. I think it's normal because I think the rule is if it's above 30, it's always normal.
Well, at least we assume that it's normal.
Yeah.
Okay.
Yeah, so I say we go with that one.
Okay. What is the mean distribution of the sample? What is the mean of the distribution of the sample means? Sampling distribution for all possible sample size samples of size 81 that could be drawn from the parent population.
So the mean is always the same, whether it's the population or the sample. So I think it's just 3.5.
Okay.
You're right. Uh-huh.
The mean's the easy one.
Yeah.
Okay.
What is the standard deviation of the distribution of the sample means for all possible sample size of 81 that could be drawn from the population? Does that stay the same also then?
No,
Yeah.
so this is going back to those three formulas that I was talking
Oh,
about.
yes.
So this is the one that has nothing to do with the z-score.
So it would be
So
0.7
it's
divided
just
by 9. So it would be 0.07777777.
so 0.078. How does it want us to run this one?
Yeah.
Yep.
Okay. What is the probability the mean of the 81 randomly selected BYUI students will be less than 3.3? 3.3 minus 3.5 divided by, so it's 0.7 divided by the square root of 81.
Negative 2.57.
So that's our z-score. Yep. That's what I got at least.
Okay.
Yeah.
257, you said?
Mm-hmm.
Yeah.
Did anyone else get 0.0051?
Huh?
That's what I got.
For 14?
13 for 13.
13. Oh.
13.
Oh, excuse me. Yeah.
Yeah, because 13 is asking for the far left-hand side only, and 14 is going to ask for the far right-hand side only.
Sorry, what did you get as your yeah. So
0.0051.
Or rounded. How does it want this one rounded? Yeah, 0.005.
Oh.
So what did you guys get for your answer? Sorry, I lost myself.
Okay, so for question 13, I got 0.005.
As the answer.
Yes.
What is the probability of the mean?
Oh, sorry, guys. Cody is asking about question number 9.
Oh.
Oh.
What hang on. Number 9.
For number 9.
0.0097.
Yeah.
Sorry, Cody, if you sent that a minute ago. I need to keep that chat up so I can see that.
Okay.
So
Okay, so then 14, so everything above 3.3 would just be 0.995 then,
wait, so for wait, what did you 0.9? Yeah, 0.995.
right? So
Yeah.
so 13 is 0.005, and then in order for it to be equal to 1, 0.995 would be
Mm-hmm.
our 14.
Okay. The United States Coast Guard assumes that the mean weight of passengers in a commercial boat is 185 pounds. The previous value was lower, but was raised after the tragic boating accident. The standard deviation of passengers' weight is 26.7 pounds. The weights of random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. From the probability that the random sample of passengers will have a weight that is as extreme or more extreme, either above or below, than was observed in the sample. I don't know if I understood the question.
Okay, so
Well,
I think
first of all, what doesn't make sense to me? Go ahead. Sorry, Brooke.
Okay, what are we trying to
What doesn't
find?
make sense to me up front, what doesn't make sense to me up front is that the mean of the population and of the sample should be the same. But they told us for the population it's 185, and for the sample it was 177.6. I'm at a loss for what this one is trying to ask.
Yes.
Um,
Mm. The United
wait,
States
it is as extreme or more extreme?
United Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers' weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have the weight that is as extreme or more extreme. So I think what we need to do is do 177.6 minus the 185, and then the 26.7 divided by the square root of 48.
Yeah, so when I
That's
do
what I
that, I
did.
get a
That's
z-score of 1.92.
negative 1.92 or positive?
Negative 1.92.
So then
Okay,
you put
me
that in the
too.
probability applet.
And then we're supposed to do everything above
Above.
that.
Yeah, that's what
Okay,
it sounds like.
0.973 then for my
0.97.
end.
Yeah. Okay. All right. Anyone want to submit? I'll go, I guess.
Okay.
Did you already submit?
No, I have not.
Okay. Yes. We missed that last one.
Was that the
And
only
looks like
one?
Is that
other.
it?
No. Number 4. So
Oh,
number
yeah.
15.
Okay.
Number 15, 12, and 4.
Hold on.
What did you put for number 12?
Number 12 has 0.778. And it needed to have 4. Oh, no, it had 3 decimals.
No, so that one just needed 3 decimal places.
Yeah.
So it'd be
0.778.
0.078.
0.778,
Point.
excuse me. I had 0.778.
So it should be 0.078, right?
No, I have. What do you guys have in it right now?
I have 0.078.
That's what I have.
Oh, okay. Then I put that wrong.
Okay.
I thought it was 778. Excuse me. So you guys should have only missed 2, 4, and 15.
Okay,
Okay.
so 4. Which of the following will have a smaller standard deviation if 9 observations were randomly drawn? So I think going back, I think Brooke, you're the one that explained this. The greater the number of observed values, you have a smaller standard deviation. If I'm remembering your explanation right,
I think.
a couple times back.
Yeah.
Which would then make the answer to this one a distribution of the sample means.
Mm-hmm.
Okay.
I think
Okay.
you and Mike both tried to explain that one to me because I don't know if I understood that at first.
Okay. Yeah, now I remember vaguely explaining that. Okay. Okay, so number 15.
Hmm.
Wait, that isn't either above or below the mean. For number 15, is it 0.055?
What's your reasoning for that?
Because, so right after it says that it is as extreme or more extreme, in parentheses, it says either above or below the mean. So if we just do like the far right and the far left, that gives us 0.0549 or 0.055. So previous to that, we had done like the middle section in the far right, but I think it's asking for the two extremes instead. Does anyone agree with me or disagree with me on that one?
You sound. I'm sorry. I'm inputting all the answers again.
I'm trying to read the question again to see if I can get a better grasp on it.
So instead of being instead of including the middle, you do the two edges, which is 0.055, right?
Mm-hmm. That's my guess on that one.
Well, why don't you? Let's see.
My reasoning for that is simply that it says that is as extreme or more extreme, and then clarifies in brackets either above or below the mean.
Yeah, that sounds right. Do you want to turn it in and see if that's it?
Yeah, I'll go ahead and submit it. Yep, that was it.
Okay.
Okay, what is it? Point.
For question 15, the answer is 0.055.
Okay. So then, did you get everything right, Brooke?
Mm-hmm.
Yep.
Do you want me to run through the answers, or are you guys good?
No, I'm good.
Good. Well, assuming I submit this and it works out for me. Okay.
Cody missed number 7. Okay, so 7 should be 0.148.
So, Brooke, could you help me understand what you did there on number 15? I'm still a little foggy.
Okay, so on number 15, I took the z-score that we had calculated, and then, so originally when we had done it, we did like the middle section and the far right, but it's asking for both for the extremes, so the lower extreme and the upper extreme. So I just highlighted the far left-hand side and the far right-hand side to get an area of 0.0549.
Okay, I get. Okay, now I see.
Okay, does that make sense now?
Yep.
Yeah, good call. That was really good because that was a really kind of awkwardly worded question.
Yeah.
All right. Well, anything else before we finish, guys?
Nope, I think we're good.
For our exam that opens next week, Is it just...
Okay, let's end the recording and then so I can post it.